All right, and welcome to Chapter 6 test. Version 1 worked out for you, 2019. Number one, if a quadrilateral is a rectangle, it is a square. It could be. If the rectangle is also a rhombus, then it is a square. But it doesn't have to be, so that's why sometimes. For number 2, all four sides of a parallelogram are congruent, then it's a rhombus. That's one of our definitions, probably our most used definition. And then number 3, if exactly one pair of opposite sides of a quadrilateral are congruent, then it's a parallelogram. It's not actually true. It doesn't have to be a trapezoid, but this isn't enough information to tell us if we have exactly one pair of opposite sides that are congruent. It doesn't give us enough information to tell us that this would definitely be a trapezoid. Definitely be a parallelogram. So let me see if I can draw one of those for you. These guys are the same. Regardless of whether these sides are parallel to each other or not, doesn't matter. Once we have exactly one pair of opposite sides congruent, it's not a parallelogram. It's not enough information. So never would be the answer for number 3. Number 4, our first apothem problem. So the regular hexagon. You're going to need to get me from the side length of 12 into the half side is 6. You're going to, one way or another, get 22.5 and 67.5. Now, this angle is 90. Work out the apothem with some right triangle trig. Take the perspective of this angle. The tangent of 67.5 is a over 6 multiplied by 6, and we'll get 6 tangent. 67.5 is a. We'll plug that into our 1/2 apothem perimeter, and we'll get the answer of 695.29, and it's in inches, so the area is inches squared. For number 5, we have a regular hexagon with a perimeter of 72, and that means that its side length has to be the side length is going to be 12 root 3. Divide 72 root 3 by 6 to get 12 root 3. That means that the half side is 6 root 3. The angles we need are 30 and 60 in our apothem triangle. We're going to get the apothem is 6 root 3 times root 3, which is 18. So A is 1/2 times 18 times 72 root 3 for a final answer of 648.3 centimeters squared. Again, getting the half side is critical, and then getting the angles of the apothem triangle. If you're going to do that, you're probably going to figure out where to go. We have a regular pentagon. We're looking at the perimeter is 40, n is 5 because it's a pentagon. Means each side is 8 and the half side is 4. The angles here are 36 and 54. Again, we'll set up a tangent of 54 is a over 4, so 4 tangent 54 is a. The area is going to be 1/2 times 4 tangent 54 times 40 for a grand total of 110 kilometers squared. Feel free to push times 2 for the speed if I talk too slow, or times 0.75 or something else if I'm talking just a little bit too fast. Also, feel free to pause or skip. It's only the problems that you missed. Number 7, if a rhombus has a perimeter of 48 inches and an interior angle of 64, what is the length of the shorter diagonal? So we've got a 64, that's this whole spanning part. In a rhombus, the diagonals bisect the angles, making this 32 and 32. I've just drawn the highlighted triangle. I figured out that since the perimeter is 48 and each of our sides are the same, the side must be 12, and that's the hypotenuse of our right triangle. The shorter diagonal is going to be across from 32, and the whole short diagonal is going to be this piece. It's going to be 2 times whatever this measure is. So we're going to get sine 32 is x over 12, get 12 sine 32 is x, which is about 6.36, which means 2x is about 12.72. We'll put inches on that, not inches squared because we're not talking about area, we're talking about a length, which is a one-dimensional topic. Find the area of the equilateral triangle. Now, a lot of people draw me the apothem triangle starting from the top. This would be an altitude. It's not quite an apothem. The apothem goes from the center to the side at a perpendicular. It's a perpendicular bisector of each side, of this side, excuse me. We get a 30, 60, 90 triangle with our apothem. Because the apothem was 8, I used a 30, 60, 90 triangle to figure out the half side was 8 root 3, the full side is 16 root 3. instead of figuring out what the perimeter was separate, I did the number of sides times the side length. So there's 3 sides times 16 root 3. Make some numbers happen, get 192 root 3. I would humbly suggest that you do half of 8, which is 4, 4 times 3, which is 12, and then pick up your calculator to multiply 12 times 16 to get the 192 with the root 3. And the units on that were millimeters squared. For number 9, you want to avoid a system. Some people might have tried to solve a system this way, and I don't know, you involve x squared with the system, and that's a little bit more complicated than we want to do. But if we use our other properties that the consecutive angles are supplementary, then we can get to x with a negative 12 and a positive 10 as our solutions. When we plug in x is negative 12, it doesn't break. In fact, this angle becomes 26. So 10y would be congruent to that. 10y is going to be 26, so 2.6 is a single y. We plug in a 10, we'll get 20 and 50 to make 70, and 70 equals 10y, that means y is going to equal 7. Number 10. If a quadrilateral is a rectangle, then consecutive angles are congruent. That is true. If a quadrilateral is a square, the diagonals create 4 congruent triangles. That is true. If a quadrilateral is a rhombus, then the angles are all congruent. That is false. They could be, but they don't have to be, therefore it's false. If a quadrilateral is a parallelogram, then the diagonals bisect the angles. That is false. They could if the parallelogram were a rhombus, but again, it doesn't have to be. The question asked us for the false one, so I chose C and D. Number 11. Again, this time we're going to embrace the system. I've solved this maybe in a way that you wouldn't think to. I've taken the 3x plus 3y equals 27 because these sides are congruent, as well as the top and the bottom. And I've divided everything by 3 to make it just a little bit easier to work with. You can do this if they all are divisible by the same number. You could do it if they weren't divisible by the same number, but it wouldn't be useful. You want to get nice, clean coefficients. So this makes it a little more simple. You get x plus y equals 9, x plus y equals 9, and then from this equation, because these two sides are equal, we can get that 14x minus 4y is 0. Put them together. Let's try to eliminate our y variable by multiplying our top row by 4. It's going to give us 18x is 36, which means x is 2. Plug it in to x plus y equals 9, and we get that y is 7. I feel like I'm yelling. Number 12. We're going to start with the fact that RT is congruent to US because this is a rectangle. Now, they give us a measure of ZS, which is a half diagonal. So we need 2 of these to equal 1 of those. We distribute, we get all of our terms to the left side of the equation to keep x squared positive. We find the numbers that multiply to 77 that add to 4. They're 11 and 7, negative, positive. The solutions, positive 11 and negative 7. Each of these give us answers. If I use that 11 for our solution, we'll get 121 minus 33, which is 88. If we use x is negative 7, we'll get 49 minus 33, which is 16. This comes to us again because in a rectangle, RT and US, the diagonals, are congruent to each other. Thank you. 13. All right, so this is a very commonly missed problem. I tried to help with it a little bit, but I might have confused you in the long run. Is it okay to use the area equals 1/2 apothem perimeter for this figure? And it doesn't tell you if this figure is a parallelogram, a rectangle, a rhombus, a square. It just tells you, well, you got this figure. So, from the information on the picture, we can tell all the sides are congruent. Therefore, it's at least a rhombus. Because it's at least a rhombus, it is a parallelogram. But we don't have anything that generates rectangle features. Therefore, we don't have anything that generates square features. So the answer is no. The figure's a rhombus. We don't know if it's a square. If it was a square, we could use our formula. However, since it's not, we cannot. Here's a long version of Number 14, you needed to list what if it was each of these, and then tell me why. So here's with sides, square root of 34. Diagonals, square root of 68. I could have simplified the square root of 68. I chose not to. And here's my reasoning. If you decide to go with slopes, I put it over here. So we have both pairs of opposite sides that are parallel, therefore it's a parallelogram. We have consecutive sides that are perpendicular, therefore it's a rectangle. These two sides are consecutive. And then the diagonals have opposite reciprocal slopes. So it's a rhombus because the diagonals are perpendicular, and it's a square because it's a rectangle and a rhombus. 15, I think one of the most challenging problems on the test. I thought you did a very nice job with it altogether. We need to pull out this triangle to figure out the side of the rhombus, and then we can, once we figure out one side, we can multiply by 4. So we've got our 16, we've got our 52, I've got an x here, and the triangle that we're looking at is right here. So from there, we'll take the perspective of 52. I could just as easily do it from 38, but I did it from 52. Cosine 52 is 16 over x. I pulled the switcheroo, I switched them diagonally. We got that x is 16 over cosine 52. The perimeter is going to be 4 times x. The perimeter is going to be 64 over the cosine 52. It's going to be 103.95 units. Not units squared, not units cubed, just units. For number 16, you're going to utilize a 30, 60, 90 triangle within a rectangle, recognizing that in a rectangle you will have right angles. And this unlocks the possibility of 30, 60, 90 triangles. 14 plus 14 root 3 is simplified, just like 3x minus 7 is simplified. It's not negative 4. It's not negative 4x. It's already simplified. So this is just what it is. 14 plus 14 root 3 is similar to 3x minus 7 because root 3 is a base just like x is a base. They're not like terms otherwise. 17, the answer is D. 18. Quite a few properties in play here. So it is a rhombus, it tells you that much. It means you have right angles here. Also means that your diagonals bisect the angles, and that all of your sides of your quadrilateral are congruent. Because 7x plus 6 is on a right angle, you're going to set 7x plus 6 equal to 90, solve from there to get x equals 12. Because 2x plus 16 is right here, this piece, we're going to go ahead and say, now that we know that x is 12, 2 times 12 plus 16 is 24 plus 16, which is 40. So this angle here is 40. This angle here is 40. With a right angle and 40, what's missing is a 50 right here. And they're asking me for the whole x, y, z. So it's 50 and 50 more to make 100. I don't know if you'll see this picture too well. I graphed the points in blue, and then I found the 3 potential vertices here, and they are 10, negative 3, 4, negative 1, 4, negative 7. For number 20, consider 2 squares, one with a diagonal of 12, and one with a, I believe it was an area of 144. So the square has an area of 144, its side lengths are 12. If the diagonal is 12 here, we're going to solve a 45, 45, 90 triangle here, dividing 12 by root 2 to get 6 root 2, multiplying 6 root 2 by 4 to get 24 root 2. The perimeter of this shape is clearly 48. The answer is 48 minus 24 root 2, which is 1406. Lastly, the bonus, please. The bonus, the interior angle is this much, the exterior angle is this much. They're supplementary to each other. You're going to get that x equals 5. Once you have that x equals 5, you'll figure out that n equals 72. Thanks so much for tuning in. Would you please complete your test corrections as soon as you possibly can? Have a nice day.